Welcome to clickmyproject.com. Let we discuss about the process ECG steganography. Let we see the abstract of the process. The common methodology in data embedding is that in the center side of the data that is to be hidden is placed within the values of the cover ECG signal producing the SIGO ECG signal. In the receiver side, the embedded data in the SIGO ECG signal. In the receiver side, the embedded data is in the SIGO ECG signal is retrieved by reversing the same process that is employed for embedding. The data that is to be hidden is embedded in the ECG signal using LSB method, a method that embeds the data inside an ECG signal with the help of LSB is proposed. The ECG signal is divided into 4 coefficients based on the DWT decomposition. The process reduces the distortions in the SIGO ECG signal, and hence the identification of the data in the ECG signal is a complicated one. The secret message in our case is our patient's data. The patient's data were initially converted into matrix, which is known as the embedding sequence. The data is hidden in the low coefficients of the ECG signal. Then the low coefficients were combined with the other coefficients. This process is employed for the whole ECG signal. The embedded bits were obtained by reversing the embedding process. The EEG signal is divided into small blocks, each using the key obtained where the message bits were located is identified. From the identified pixel location, the embedded sequence is obtained. The embedding sequence is reconstructed into a message. The pixel pair matching provides the improved performance of the embedding process. The neighboring pixel points in the EEG signals were identified based on the embedding data, and they are replaced by the data. For the identification of the neighboring results, the pair matching processes were employed. The regions that were after the message bits were selected and the message bits were embedded. The overall performance of the process is measured with the help of compression ratio, PSNR, and MSE of the process. Let me see the flow of the process. The input EEG signal is first taken. After that, the basic pre-processing like the filtering of the signal and decomposition of the signal is employed. For decomposition of the signal, discrete wavelet transformation is employed. The input ECG signals were taken and they are decomposed using the discrete wavelet transformation. After that, the embedding process is started. In the embedding process, the input ECG signal, the low coefficient of the ECG signal is taken. The secret information is got from the user. Here the secret information refers to the patient details in the system. After obtaining the patient details, the details were embedded in the low coefficient of the ECG signal. After that, for the embedding process, LSB replacement is employed. The in, the informations were placed in the LSB of the ECG signal. After that, the embedding process has been completed. The the signal is inverse transformation is applied to the signal with the modified low coefficient and the other coefficients in the signal. This process will happen in the sender side operations, and after that in the receiver side the process is exactly reversed. That is, the obtained ECG signals were initially decomposed using discrete wavelet transformation. After them, the decomposed videos where the low coefficient was taken, and then the the informations in the LSB where the patient details, they were extracted from the signals. Thus, we have embedded the patient information within the ECG signal, and we have extracted the same from the ECG signal. The overall performance of the processes is measured with the help of the comparison of the input and the output signals with the help of the embedding ranges and the PSNR and the calculated values. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. Select the file in any one of which is select any one of the input signal, and the obtained input signal is plotted here. After that, we obtain the data from the user. So first we give some two datas, we get some two datas from the user. So first data, let us assume it be temperature, and we enter that. After entering this, we enter the temperature values. After that, we give some blood pressure value, and then the value is given. After the blood pressure value has been given, the values will be displayed. This is the secret data. After that, this secret data is encrypted. After that, this encrypted data is embedded in the original input ECG signal. So after embedding process, this window will be displayed regarding if we want to transmit the data or not. So if we want to transmit means we have to give yes like this. After giving that, the receiver side window will be open, and as we can see, the encrypted data is calculated in the form of a mat file, and after that this is transformed to the this window. So first we retrieve the data from the signal. So this is the DWT coefficients obtained in them. After that, this is the temperature and the pressure, which is in the encrypted format. After that, the data is decrypted to retrieve the original temperature and the blood pressure, and this is the original output signal that we have obtained. Finally, our performances is measured in terms of MSC, PSNR, and bits per pixel, that is the embedding ratio. So this is the comparison of the MSC process. So the comparison of the MSC process is done by comparing the signals before and after the embedding processes. So before embedding means the input signal and the pre-processed signal is taken, and after embedding means the input signal and the final retrieved signal is compared. And for the PSNR comparison also, the similar value is got, and based on that this comparison chart is obtained. So thus we have embedded the secret information in the ECG signals, and we have retrieved the same, and also we have transmitted the patient information along with them. Thank you.